Hi, in this video I'm going to go through all the calculations that are required to plan out a set of stairs. Plan out a set of stairs, there are a number of questions you need to answer. The first one is how far is it from the finished floor to the finished floor? That number is called your total rise. When you're building a house, you're going to build your stairs before the finished floor goes in. So you need to take into account the thickness of the finished floor when you're doing this calculation. Generally speaking, you'll be measuring from the plywood subfloor to a plywood subfloor. And if the finished flooring that you're putting on top of the subfloor at a later date is exactly the same on the bottom floor as it is the top floor, as it is in this house, then your finished floor to finished floor should be the same distance as subfloor to subfloor. If you're going to be putting different materials on the top floor than you are on the bottom floor, then you're going to need to take the material thickness into account. For example, tile is often a 1/2 inch thick, and it might be more depending on what kind of substrate that you put underneath it. And a hardwood floor, a laminate floor could be as thin as 3/8 of an inch. Very, very important to take those measurements into consideration when you're doing this measurement. In this house, the distance from finished floor to finished floor is 114 inches. The next question you need to answer is, how many steps will there be? That question could also be phrased as how many risers are there? In this house, there's 15 risers. The third question is how big is each step going to be? Or what is the unit rise? In this house, because of the total rise being 114 inches and each stair needing to be the same, I chose to go with 15 risers, each riser being 7 5/8 of an inch. And I'll be going through the calculations that I used to get that. Please note that the BC Building Code has got close tolerances for the size of the risers. When the inspector comes in and checks the distance from tread to tread, any tread adjacent or any adjacent riser must be within 5 millimeters of the one next to it. And when you measure all the rises individually, the largest rise must be within 10 millimeters of the smallest rise. So it's important that you not only calculate exactly what your unit rise should be so that they all are mathematically similar, it's also important that when you go to cut them, that you do your best to make sure that you cut them accurately so that they are all within those tolerances. The fourth question is how deep will each tread be? Remember, tread depth is the distance from the nosing to the riser board. Tread depth is the sum of the unit run, which is from the riser board to the riser board, plus the nosing. In this house, the tread depth is 11 1/8. I've got a unit run of 10 inches and a nosing of 1 1/8, and 10 plus 1 1/8 is 11 1/8. So the next thing I'm going to show you is the formulas or the math behind calculating those numbers. Okay, here I've drawn a basic plan of my set of stairs. So as you can see, the total rise is 114 inches. And I've labeled the unit rise, plus I've labeled the total run. That's a fairly easy calculation that we'll talk about later. Up in the top right-hand corner, I've drawn a bubble around something called an ideal stair. An ideal stair is just a stair that uses measurements that over time people have determined to be the most comfortable stair. As you can see, I've labeled the run at 10 inches and the rise at 7 inches. In metric, those would be 180 millimeters for the rise and 250 millimeters for the run. Now, clearly, we can't build stairs that all have 7-inch rises because that would limit you to total rises that were multiples of 7 inches. For example, if we had a total rise of 49 inches, we could build a set of stairs that had 7-inch risers because 7 times 7 is 49. In my case, 7 doesn't go evenly into 114 inches, so my stairs can't be 7 inches. That's just an ideal that we're aiming for. So this page here goes over the math for calculating how many risers we're going to have. So the number of risers is equal to the total rise divided by the desired rise. The desired rise is the number on the last sheet, or 7 inches. So if you're doing it in imperial, it would be the total rise divided by 7, and if you're doing it in metric, it would be the total rise divided by 180. millimeters. And then I've done an example there. Example, a number of risers in my house is 114 inches divided by 7 inches, which gives us 16.28 risers. Now you clearly can't have 0.28 of a riser. You can have 16 risers, you can have 17 risers, but you can't have 16.28 risers. So this number you're going to round. And in fact, you actually have quite a bit of leeway on how far you can round it. As we've talked about already, my stairs have 15 risers. The reason my stairs have 15 risers and not 16 risers or 17 risers, which also would have been okay, was because the amount of space in my house was limited, and so I chose to make steeper stairs by using fewer risers because there would be fewer treads or fewer unit runs. The more unit runs you have, the longer the total run. As you should be able to see from this drawing, the total run is just the sum of all the treads added together, or all the unit runs added together. If each one's 10 inches, my stairs would have a total run of 140 inches, because I have 14 treads, each one having a run of 10 inches. If I'd gone with 16 risers, I would have 15 treads, each one having a run of 10 inches, and that would have made my staircase 10 inches longer than it currently is. And that would have limited the amount of space at the bottom of my stairway. So in conclusion with this particular formula, just know that the 16.28 gives you a place to start. It's not a hard and fast number. You don't have to choose 16. You don't have to choose 17. You're just going to be choosing a number somewhere around 16 or 17 that lets you build a set of stairs that falls within the building code guidelines. Okay, the next question you need to ask, or you need to answer actually, is what will the unit rise be? Remember, the unit rise is the distance from the finished tread to finished tread, or it's the distance your foot moves every time you take a step. So on my set of stairs, I have a total rise of 114 inches, and I know that I want to have 15 steps in there. The formula to find the unit rise is the total rise divided by the number of risers, or the number of steps. So as you can see in my house, I've divided 114 inches, which is the distance from finished floor to finished floor, by 15, which is the number of steps I wanted. 114 divided by 15 is 7.6. And 7.6 is very close to 7 5/8, which is in fact the rise when measured on my set of stairs. When you're calculating the unit rise, you're not done when you have a measurement. There's one more critical step you need to take, and that's to make sure that the measurement that you've come up with fits into the constraints that the building code sets out. To do that, if you're working in imperial, you'll need to get a number in metric. So I've done that. 7 5/8 of an inch is equal to 193.7 millimeters. So now I go into 9.8 and I look that up. And on page 313 I see a chart. And the chart gives me rise for rectangular treads, which is what I have. And you'll notice that the chart's got two rows, one for private stairs and one for public stairs. And it's got a minimum and a maximum. And the first row, the top row, is for private stairs. And you'll note that for private stairs, the maximum rise is 200 millimeters and the minimum rise is 125 millimeters. My stairs are 193 millimeters, which falls in between 200 and 125. So therefore, for private stairs, my rise is acceptable. Please note that public stairs have a maximum rise of 180 millimeters. If I had built these stairs as public stairs, in other words, stairs that were inside an institution that the public could access, then the rise that I've chosen, 7 5/8, would be too big. The last two basic questions you need to answer are how many treads are you going to have, and how big will each tread be? The number of treads is pretty easy to figure out. It's just the number of risers minus 1. So in our case, I have 15 risers, therefore I have 14 treads. Unit run and tread depth are linked. In fact, the unit run and the tread depth are allowed to actually be the same. On my stairs, I decided to have 1 1/8 inch nosing. That was to allow for the trim that I've put underneath the stairs, or underneath the stair treads. But typically, nosing's 1 inch. I also use 10 inches for my run. Therefore, on a set of stairs that I build, I usually have a tread depth of 11 inches and a unit run of 10 inches. That makes calculating my total run pretty simple also. The total run is just the number of treads times the unit run. So in my case, it'd be 14 treads times 10 inches, or 140 inches. Please note that just like riser boards, the building code has got limits on how big the tread can be, both a maximum and a minimum. And just like risers, there's different numbers for private stairs and for public stairs. For private stairs, the maximum tread depth is 355 millimeters, and the maximum run is 355 millimeters, and the minimum run is 210 millimeters. The tread depth maximum is 355, in other words, exactly the same as the maximum run, and the minimum tread depth is 235 millimeters, which is 25 millimeters more than the minimum run. So in other words, if you're going to build a stair with the smallest run possible, you need to have 1 inch of nosing on the edge of your treads. When I was in carpentry school, and in your textbooks, when you get to this portion, you'll notice that there is something called stair proportioning rules. These are rules that carpenters have developed to describe the relationship between the rise and the run. So there's 3. The first one is the rise plus the run equals 17 inches. The second is twice the rise plus the run is 24 inches. And the third one is the rise times the run is 72 inches. You'll notice that if you use 7 inches and 10 inches, or the measurements I described in an ideal stair, that those numbers work out almost exactly for each one. 10 plus 7 is 17. 2 times 7 is 14 plus 10 is 24. That's the middle one. And the last one says the rise times the run is 72. Well, 7 plus 10 is 70, and 72 and 70 are pretty close together. I don't use these. I just use 7 and 10 when I build stairs, and understand that 7 is a goal that I will only meet on stairs that have a total rise that is a multiple of 7, and I use 10 pretty much every single time. So to recap, here are the basic stair formulas. The first one is the number of risers. How many steps are there going to be? The number of risers is the total rise divided by the desired rise. Use 7 inches or 180 millimeters for your desired rise. The next is, what is your unit rise, or how big is each step going to be? To find that, unit rise is equal to total rise divided by the number of risers. The next is, how many treads will you need? The number of treads is equal to the number of risers minus 1. It's kind of nice to know how long your stairs are going to be. That number is called the total run. The total run is the number of treads multiplied by the unit run. Because I just about always use 10 inches for my unit run, that formula would be number of treads times 10. And lastly, the tread depth is the unit run plus the nosing. And again, because I usually use 10 inches for my unit run and 1 inch for my nosing, the tread depth on a set of stairs that I build is typically 11 inches.